one. And just like functions, you can bake these, because again, they're just functions. So here, we're going to bake. So for the functional language people in the audience, baking is a compile time currying where you take the old version of this function and you generate a new version of the function with this value substituted, and then all compile time optimizations are applied because this entire function is computed at compile time, right? Not that it matters much for this function, but we're just going to show we're baking a version of locally scoped macro. It gives us a new macro where 69105 is hard-coded as this parameter. We're actually going to use this later in this demo. If this seems like a weird feature and you're like, what's that for? You'll see. But anyway, so then we call baked with no parameters because it used to have one and we baked that parameter and now it has 0 parameters. Okay, named arguments, just like functions. So here's a macro A and B. It takes A, it takes B. Uh-oh, I jumped ahead, so we're going to have to explain this feature. Oops. This is what happens when I rearrange the order in which I demo things a few times. Let's ignore that feature for a second. So we have A and B, it takes 2 strings, and we put them together with some join variable. Well, I have to explain. So it's a hygienic macro, so it doesn't have access to your variables, or you don't have to worry about namespaces colliding unless you want them to, right? So the backtick in front of join says, actually, let's refer to this variable from the calling scope, right, of where we're inserted. So here, we're making a thing called join. It's got like A spaceship B or whatever. And we're calling A and B with B as sailor and A as hello, right? We're using named arguments. So we're using just all this tooling that we have available for calling functions, and it works just fine on macros, the same as functions, right? So this wouldn't work on a function. You would have to pass join in somehow, but it works here, right? Well, you could almost imagine it working because this is lexically scoped here, but like if we put it outside this function, then it would surely have no way to see this. And yet it would still work because it's a macro that gets pasted in. Varargs, we already did varargs. I didn't notice that I have 2 varargs demos. Anyway, so here's a varargs that puts a defer, which is again gives it a reason to be a macro. It's defers and for all the values prints them. And so we're doing dimwit first and then flathead, even though the calls are in the reverse, because defer executes in stack order, which is what you want for destroying and closing things, right? So we do dimwit first, and then we do flathead. OK. So this is where I was efficiently really going to explain backticks. So here I've got a value. I've got a local variable. It's called value. It's bound to the string local. I've got a macro called backtick macro. And backtick macro says I'm able to access value. It is whatever, right? So we have a backtick in front of this, even though this doesn't have anything called value in its scope. It's able to look up to the scope of the person applying it. Now notice this time it's not in function scope either. It's like at global scope. So, you know, really the only way that we're able to see this is because this is a macro that's being inserted directly into the syntax tree, right? OK, where are we? I am able to access value. Here we go. I'm able to access value. It is local. So now we can have this backtick macro, and it'll look at both values. So here I have a value called value bound to the macro, meaning the macro scope. I've got another version of value out here still called local, right? And so here we're going to enter this macro. We're going to look at, this is just a label, right? So we're calling this with the label first or second. So we're going to say we entered first or entered second, and we're going to say what the value is. And this is just our value, right? But then we're going to say backticked value, and we're going to access the one from the enclosing scope. And then to give this a reason to be a macro again, we're going to use a defer at the end. Here we go. We entered first, value is macro, backticked value is local. Entered second, value is macro, backticked value is local. And then we defer close the second, right? And defer close the first. Okay. Are there any questions so far? Very on-topic questions. I've been glancing at chat. I've seen very off-topic things go by. But like questions about how this works before we go on, because these are like basics, and I'm speeding through it. I'm sort of assuming you know what a macro is. I'm assuming you know the pitfalls of C macros and why it might be good to do things this way and so forth. Can you use macro in macro? Yes, we will have an example of that later. Can you apply expand at the call site? There's not really a reason to do that. Expand at a call site would be the same as inline. Because if the body of the macro isn't written knowing that it's a macro, there's like no reason. Can macros have polymorphic arguments? Yes, I believe we have an example of that later. How does the macro backtick feature differ from a capturing lambda? It is different because we're not making a separate function, and that has a number of ramifications. One, you don't have to worry about getting optimized out. Two, you can use little snippets of code and pass them to macros in ways that are less bulky than you would if you had to make a lambda. We'll show that later. If the macro has its own scope, how does a defer happen on the caller? Well, it's a little bit magical, right? So what happens is there's a scope. The scope of the macro contains the macro's own names, but it's transparent to certain kinds of things. Defers is one of them, and we're going to go into another one of them in a minute. So it's not a naive separate scope, let's put it that way. All right, there's a lot of questions. I'm just scanning really fast for anything that might, like a lot of these questions are about things I haven't covered yet, so I'm going to skip those. Can you bake with a reference to a local? Any parameter to bake has to be a constant. That's the way it works. So if it evaluates to a constant, sure. Otherwise, no. Doesn't the backtick feature make it unnecessarily complex? Wouldn't argument make the code clearer? Well, if you can write something as a function, write it as a function. Sure. The reason the backtick exists is to do things. Okay. The point of a macro. Well, let's go back one step further. The point of a strongly structured programming language that gives you functions with very well-defined lexical scope is that that's a very good way to organize programs generally, right? It cuts down on mistakes. If I use a variable, we don't just pretend it's empty string, we say it's undefined. Why? Because that cuts down on mistakes. It helps you produce code that is not very error prone. Okay, however, sometimes you just need a way to get out of that structure because it's much more efficient to do something outside that structure, or it's much more understandable even, right? That's why macros exist in C, is because sometimes you just got to do stuff that's not like functions, right? And that's why macros exist here. So if you're asking why all this backtick stuff, it's because it lets you do things that are outside of that normal system of strict lexical scoping. And that's useful. And we're going to show in the rest of this some of the ways in which that's useful, right? Okay, a lot of this is stuff that we're going to cover later. Can a macro return another macro? Yes, although I hadn't thought to demo that, but yes. They're literally just functions. Although you would have to apply it at compile time, otherwise it's just a macro, right? Okay.